You don't try and go into space and up to the moon and Mars and build space stations and so on so you can escape the Earth when you've messed it up. It is the opposite.
When Brian Cox spoke last night under the shimmering dome of the Royal Institution, his voice carried the weight of revelation as he described an astonishing observation. The James Webb Space Telescope had recorded an abrupt and unprecedented surge in Betelgeuse's luminosity, a spike of nearly 250% in a matter of days. Across the audience, telescopes and smartphones alike turned their lenses toward the shoulder of Orion, where this red supergiant, famous for its capricious dimming episodes, had now brightened far beyond anything recorded in human history. The cosmic drama unfolding in our night sky seemed to beckon a new chapter in humanity's understanding of stellar life cycles, and for a moment, the boundary between professional astronomers and stargazing enthusiasts seemed to blur, united by shared wonder and a rush of anticipation. Before we start, hit the like and subscribe buttons for more exclusive news. Betelgeuse has long captivated observers with its titanic bulk and temperamental brightness. As a red supergiant nearing the end of its life, it occupies a precarious position on the brink of supernova. Over the past decades, it has offered glimpses of its internal turbulence. The great dimming of 2019, when dust clouds and shifting convection cells cloaked much of its light, and earlier pulsations that ebbed and flowed over months. Yet nothing prepared the scientific community for the James Webb's revelation of a 250% increase, an explosive flare that defied the more gradual pulses predicted by existing models. This abrupt intensification challenged long-held assumptions about red supergiant behavior and opened a window onto processes so extreme and fleeting that only Webb's infrared sensitivity could capture them. The implications of such a dramatic brightening are manifold. At its core lies the question of stellar stability. Traditional models suggest that red supergiants like Betelgeuse undergo fairly steady pulsations driven by the interplay of radiation pressure and gravity, modulating their radius and brightness in predictable cycles. A sudden energy deposition on the scale implied by a 250% rise hints at a cataclysmic internal event. Perhaps a convective surge ripping through deep layers, or an incipient nuclear flash in the helium shell. Such occurrences, if confirmed, would require a fundamental reevaluation of how massive stars approach their terminal supernova phase. With Webb's ability to peer through dust and into thermal emissions, astronomers now have the tools to probe these hidden convective hearts with unmatched clarity. The excitement is palpable not only in academic circles but among the broader public. Images and data shared by the Webb team have flooded social media feeds, with artists rendering Betelgeuse's fiery surface in swirling reds and oranges. Amateur astronomers are recalibrating their telescopes and adjusting observing schedules, eager to witness this celestial upsurge. Planetariums are scrambling to create special programming, and science journalists are racing to explain the significance in lay terms. In classrooms around the world, students peer at online light curves and spectral graphs, grappling with concepts of stellar atmospheres and exotic nuclear reactions. The effect is a collective rediscovery of wonder, a reminder that even a well-known star can harbor secrets that shift our cosmic perspective overnight. One of the first avenues of inquiry centers on spectroscopy. By dissecting the light of Betelgeuse across wavelengths, researchers hope to pinpoint changes in its chemical signatures. A 250% brightening may reveal fresh dredge-up of heavy elements from the star's core, temporarily brightening specific infrared and optical bands. Early spectra from Webb show enhanced emission lines of ionized calcium and titanium, hinting at shock waves reverberating through the outer envelope. If these shock fronts are indeed propagating outward, they may accelerate mass loss, shedding enriched material into the interstellar medium. Over time, this could seed future generations of stars and planets with elements forged in Betelgeuse's fiery guts, underscoring the star's role as both destroyer and creator in the cosmic cycle. Moreover, the energy scale of the brightening raises tantalizing questions about the star's internal dynamics. Could a helium shell flash, similar to those observed in lower mass stars on the asymptotic giant branch, occur in a red supergiant? Theoretical work has long suggested that advanced nuclear burning stages, such as carbon and neon burning shells, could become unstable, but direct observational evidence remained elusive. With Webb's sensitivity to mid-infrared emissions, scientists can now search for the thermal signatures of such flashes, which may manifest as brief, localized hotspots on the stellar surface. By mapping the temperature distribution across Betelgeuse's disk, astronomers aim to identify the footprint of these nuclear cauldrons, offering a real-time glimpse into the processes that govern stellar evolution at its most extreme. The broader astrophysical community is mobilizing to complement Webb's findings with multi-wavelength observations. Radio telescopes will scan for non-thermal emissions indicative of magnetic reconnection events, while X-ray observatories could catch high-energy bursts from shock-heated gas. Ground-based optical interferometers, including the Very Large Telescope Interferometer, VLTI, will attempt to resolve surface features, potentially capturing a bright plume or hotspot erupting from Betelgeuse's photosphere. Coordinated campaigns could reveal how the brightening propagates through different layers of the star, from its convective core to the tenuous outer atmosphere. This synergy of instruments across the electromagnetic spectrum transforms Betelgeuse into a cosmic laboratory, where every photon tells a story of turbulent physics and stellar metamorphosis. Beyond the astrophysical insights, the brightening has ignited philosophical reflections on humanity's relationship with the cosmos. Betelgeuse, visible to the naked eye even from light-polluted cities, becomes a touchstone for contemplating time and scale. The flare that unfolded over days is but an instant in the star's million-year march toward supernova. Yet for us, those days of heightened brilliance prompt questions of permanence and change, how civilizations look to the heavens for constancy, and how the universe reminds us of its restless dynamism. Poets and philosophers alike draw inspiration from this burst of starlight, weaving metaphors of renewal and fragility. The glow of Betelgeuse resurfaces myths and stories across cultures, from ancient desert caravans to modern astronaut crews, all under the same stellar gaze. Public engagement efforts have surged in response. Science communicators are hosting live Betelgeuse Watch sessions, translating raw data into accessible visuals in real time. Educational platforms have launched interactive simulations, allowing users to tweak parameters of nuclear burning and observe how surface brightness responds. Virtual reality experiences transport participants onto Betelgeuse's surface, where they can witness shockwaves rippling through crimson gas. These immersive projects do more than entertain. They foster scientific literacy, inviting laypeople into the process of discovery. The sense that anyone, anywhere can connect with the star's changing light cultivates a shared stewardship of our cosmic heritage. In parallel, theorists revisit long-standing puzzles. How do magnetic fields influence mass ejection in late-stage red supergiants? Could magnetoacoustic waves deposit enough energy in the outer layers to trigger rapid expansion and brightening? Webb's data, combined with polarimetric measurements, may reveal the interplay between magnetism and convection, a domain where computational models have struggled to keep pace. Enhanced brightness could also signal the formation of dust grains in the cooling wake of shock-heated gas, temporarily altering the star's opacity and thermal profile. By observing how dust production ramps up, or fails to, scientists gain clues about the chemical evolution of galaxies and the origin of interstellar grains that seed star and planet formation. On a more practical level, the event underscores the transformative power of the James Webb Space Telescope. While its initial mandate focused on the early universe and exoplanet atmospheres, Webb's keen eye has now proven invaluable for time-domain astronomy closer to home. Detecting rapid changes in a familiar star highlights the telescope's flexibility and potential for unanticipated discoveries. Future proposals for observing proposals may prioritize monitoring campaigns, dedicating segments of Webb's schedule to revisit key targets like Betelgeuse at critical junctures. This shift toward responsive, event-driven observations reflects a new era in which space telescopes not only peer back in time, but also capture the dynamic present unfolding across our galactic neighborhood. The implications extend to the field of early warning for supernovae. Betelgeuse's brilliant surge could serve as a precursor signature, a harbinger of more dramatic events to come. If astronomers can correlate sudden brightening episodes with subsequent structural collapse or neutrino bursts, they may develop predictive frameworks for imminent supernovae. Such frameworks could alert neutrino detectors and gravitational wave observatories to prepare for the faint tremors of core collapse. In essence, by watching Betelgeuse's light curve with unprecedented fidelity, scientists hope to refine the cosmic alarm system that heralds one of the universe's most spectacular finales. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on Betelgeuse's 250% brightness spike? We want to hear from you. Thank you for watching and see you next time.